This lecture will be an introduction to microservices, where we'll be explaining what a microservice architecture is and its advantages and drawbacks, which will help us decide in which scenarios this architecture is applicable. A microservice architecture is based on services and their intercommunication. So, in other words, the system is structured as a collection of interconnected services. The services are fine-grained, which means they each perform a specific function or task, and they are lightweight. We'll be talking about how to split a system into different microservices in another lecture. For the purpose of this introduction, it's important to note that the services are loosely coupled and that a service logically represents a business activity with a specified outcome and is self-contained. It is a black box for its consumers, which shouldn't need to know anything about its inner workings, and it may consist or make use of other underlying services. I've added this diagram here, which illustrates how different microservices making up the entire system communicate together and provide functionality to the UI. The advantages of microservices are that since services are loosely coupled, there is low coupling between components, which improves modularity, making them easier to develop, understand, and test. It promotes parallel development, as different microservices can be developed by different teams using different technologies. And the microservice architecture also promotes scalability, although if not developed carefully, it is still possible, of course, to develop a system with microservices that does not scale well. The drawbacks of a microservice architecture are that the infrastructure costs are usually higher due to the need to support a higher number of services and the inter-process communication. Integration testing also becomes more complex because of the number of microservices that need to be tested together. Service management and deployment also becomes more complex. And we must be careful to avoid the nanoservice anti-pattern. A nanoservice is an anti-pattern where a service is too fine-grained. In this case, the service's overhead, such as the inter-process communication overhead, serialization costs, etc., outweighs its utility, and in such cases, it would make sense to package this functionality into a software library or combine it into other services. Another thing to note is that graphical user interface-based applications may not be suitable candidates for a microservice architecture, especially if these require a lot of data exchange between services.